Alright, so hi guys. I was gonna upload a video, but apparently I was editing it and it was just not saving. So in this video, we are gonna go over improper integrals. Now, I'm not gonna go over every single theorem because there's a lot to this, and I am gonna try to do maybe a 3-part series, or I don't know how many parts it'll be, but we're gonna go ahead and do these. So let's see, hold on. Let me write some rules down. Okay guys, give me 1 second. Okay guys, sorry about that. I was trying to make one up. Okay, so we're gonna go ahead and do this one. I did write a rule down. Let me go over that rule really quick. So, if f is continuous on the interval a to infinity, then the integral from a to infinity of f of x dx equals the limit as b approaches infinity of the integral from a to b of f of x dx. Now, I don't want to do one using L'Hopital's rule because I don't know if I've gone over that well enough on my YouTube channel. So we're gonna just do this one. The first thing here is that we need to integrate this stuff over here. Okay, and so we're gonna go ahead and do that. So 3 over x squared plus 1 dx. This can be equal to 3 times the integral of 1 over x squared plus 1. So remember that constant property. We take the constant out and move it outside of the integrand, or the integral symbol. I can't remember if it's the integral symbol. I don't know if it's integrand or integral symbol, but we basically move it outside. And so we're gonna evaluate, or we're gonna simplify this integral. Remember that the integral of 1 over x squared plus 1 dx is arctangent of x. Mostly they use arctan. So we know that this is really going to be 3 times the quantity arctan of x. And then it's going to go from 0 to infinity. I'm sorry, from 0 to b, excuse me. So really, we're doing this formula. It's the integral from 0 to infinity. Or really, this is the integral of 1 over x squared plus 1. So let me first write that down. Okay, and now we're gonna use this here. We're gonna use this right here to do the following. So it's gonna be the integral from 0 to infinity. And actually, I meant to put this outside, of 3 over x squared plus 1 dx is equal to 3 arctangent, is equal to the limit as b approaches infinity of 3 arctangent of x. And this is gonna be from 0 to b. Okay, guys. Here, we're gonna go ahead and evaluate this. Now, we know that this is gonna be 3, and it's gonna be 3 arctangent of b minus 3 arctangent of 0. And it's the limit as b approaches infinity, excuse me. We're using fundamental theorem of calculus here. Remember that fundamental theorem of calculus is the integral from a to b of f of x dx is equal to some antiderivative f of x from a to b, which is really just f of b minus f of a. So that's the fundamental theorem of calculus, and that's what we're doing here. So we know that when we do arctangent, and I do believe, 1 second, guys. Okay, guys, so we want to remember that the limit as b approaches infinity. So this entire thing, actually, let's go ahead and take out the 3. So we're going to say the limit as b approaches infinity of 3 times the quantity arctangent of b minus arctangent of 0. And so this is going to end up being the following. 3 times the limit as b approaches infinity of arctangent of b minus, and arctangent of 0 means if tangent of theta is 0, where is, and at what angle is tan theta equal to 0? Well, if you think about it, on our unit circle, on the point, let's do, if at 0 pi radians, we have 1 comma 0. And if you think about it, tangent of 0 is 0 over 1, because remember that tan theta is y over x, where we have a coordinate x comma y. So you have to know your trig right there. And so we know that that this is going to be 3 times the limit as b approaches infinity of arctangent of b minus, and it's going to be, and actually, let me do it like this, hold on, of arctangent of b minus the limit as b approaches infinity of arctangent of 0. And like I said, this is 3, and remember that the limit as x approaches, as b approaches infinity of arctangent of b is going to be pi over 2. So we have pi over 2, and then the limit as b approaches infinity of arctangent of 0 is just going to be 0. So that is what it is. And so we're going to do pi over 2 minus 0, and so therefore we have 3 pi over 2. So I do believe that if this is equal to a finite number, if the integral from a to infinity of f of x dx equals some constant L, then the integral converges. The improper integral converges. I think. We're not going to go more into it until another video, but this is just one of the rules. And if I am wrong, somebody please correct me. I do think this is what it is, but this is just an introduction to improper integrals. So therefore, the integral from 0 to infinity of 3 over x squared plus 1 dx, thus the integral from 0 to infinity of 3 over x squared plus 1 dx is equal to 3 pi over 2. And this is our final answer. And because the integral from 0 to infinity of 3 over x squared plus 1 dx equals a finite number, the integral converges. If it were like infinity or something like that, guys, then it would diverge. I can't remember if it's equal to 0. I can't remember if it converges or diverges, but if it equals a finite number like 1, 2, 3, 4, etc., then it converges. So that is gonna be it for this problem, guys. If anybody has any questions, please let me know. And thank you so much for watching, and also please like, comment, and or subscribe. And I will see you guys in the next video. Bye, guys.